Hello ladies and gentlemen, today we're going to discuss how to multiply and divide fractions. This is chapter 14, section 3 and section 4. Yesterday we reduced fractions. When you want to reduce fractions, let's come up with a way to help us remember that. When we reduce fractions, there's basically two steps. Step 1 is going to be to factor, and step 2 will be to cancel. Anything you can cancel out of the top and bottom. We can remember that as FC, F for factor, C for cancel. We'll use that same kind of idea here with multiplying and dividing fractions. If you scroll down for a minute, you'll notice that the rules for multiplying fractions are already here. When we multiply fractions, we're going to factor first. Once that's done, then we'll cancel anything out of the top and bottom that we're allowed to cancel, and then we will multiply. So multiplying is actually the third step. FCM, factor, cancel, multiply. Factor, cancel, multiply. Take a look at problem 1 here. Factor, that's not necessary. There are no binomials on the top and bottom, so there is no factoring to do. Cancel, 7 goes into 7 one time. 9 goes into 27 3 times. So I'm left with 1 times 1 on the top, 3 times 1 on the bottom, which is 1 over 3. And you can see a little bit different way to look at that down below. Number 2. First thing I'm going to do is factor. There are no binomials on the top and bottom. Cancel. There are no common terms on the top and bottom. Can't cancel the y because there is no y on top. Can't cancel an x. There is no x on the bottom. Same with a and b. Step 3 is to multiply. This becomes a times x, b times y. The rules for multiplying fractions. Top times the top, bottom times the bottom, and this would be your final answer. For 3, a lot of work we can do here. Cancel. We can't factor, so f is skipped. There is no factoring to do. We're going to cancel. X squareds cancel. One of these y's is going to go away. I'll be left with a single y left over. 5 goes into 15 3 times, and 7 goes into 14 2 times. So what's left over is 2y. Another way to look at this is 5 times x times 14 times y. On the bottom, that's 7 times y times 15 times x. And then when I want to cancel these things out from the top and bottom, I can get rid of an x on the top and bottom, another x on the top and bottom, a y on the top and bottom. 14 is actually 2 times 7. 15 is actually 3 times 5. That's the prime factorization of those. So I can get rid of a 5 on the top and bottom, and I can get rid of a 7 on the top and bottom. So you're left with 2y on top. And look at this. By doing that, I found a mistake. I need a 3 on the bottom. 2y over 3 would be the correct answer. Okay, now problem 4. Now, because there are binomials, expect to have to factor. We have a squared minus b squared, which is different to 2 squares. The square root of a squared is a. The square root of b squared is b. And remember, when doing difference of 2 squares, we want a plus sign and a minus sign in there. This is 10x cubed. We'll leave that alone for now. Same thing with a 5x squared. We'll leave it alone for now. On the bottom, 2a plus 2b has a greatest common factor of 2. I factor it out. Don't get rid of that 2 though. It should be there. Alright, let's see what we have here. I have an a plus b on the top and bottom. I can get rid of it. 5 goes into 10 2 times. I have 2 x's on top. I have 3 on the bottom. I'll be left with an x. So what's left over? An a minus b on the top, a 2, an x, and a 2. And what's 2 times 2? 4x on the bottom. The problem is done. Number 5. 3x plus 15 can be factored. It has a greatest common factor of 3. Everything else is going to carry along to the next step. We'll worry about it now. 2 goes into 4 2 times. The 3's cancel. 3 goes into 3 one time. Is technically what's going on there. So we're left with x plus 5 on top. Everything else has been canceled out. 2y on the bottom. Box it up. And there you go. Alright, number 6. Haha, look at this. We're kind of in good shape here, and That's because I don't have any binomials to factor, so I'm going to skip the factoring step and go right to the canceling step. Check this out. Let's just write all the stuff out. This is much longer, obviously, because you're writing all that out, but it does work. Get rid of an A, get rid of another A, get rid of another A on the top and bottom. I can cancel an X out of the top and bottom, and I can cancel a B out of the top and bottom. So what's left over? 5 times 2 is 10, 10 times 3 is 30. There is nothing left on the bottom, so there's no need to put that over 1. 30 is fine. 7's a spicy little problem. Check that out. We have x squared minus 25, difference of two squares. Square root of x squared is x, square root of 25 is 5, and we'll go plus minus. On the bottom, another difference of two squares. The square root of 4 is 2. The square root of 9 is 3, and the square root of x squared is x. And then we go plus minus. Over here, the 2x plus 3 can't be factored even though it's a binomial. X minus 5 cannot be factored even though it's a binomial. So they just carry along. You cannot cancel anything out of the top and bottom unless it is an entire term. So I am going to be able to cancel x minus 5 out. I am going to be able to cancel 2x plus 3 out. Look what's left over. You have x plus 5 on top, 2x minus 3 on the bottom. That's done. You cannot cancel an x out of the top and bottom because there is no x. That's x plus 5 on top. So whatever you put in for x, you have to add 5 to it. They can't be broken apart. They're going to stay together. Alright, problem 8 here. We have a trinomial, so off on the side somewhere, we'll do our puzzle. We're talking factors of 12 that add to be negative 7, which is negative 4, negative 3. So that's x squared minus 4x minus 3x plus 12. That's x times x minus 4 minus 3 times x minus 4. So when that's all done, you're going to have x minus 3 times x minus 4 on top. On the bottom we have difference of two squares. Take the square root of x squared, take the square root of 4, put a plus minus in there. 2x plus 4 has a GCF of 2. And the x minus 3, we can't touch it. We can't do anything with it. So let's take a look here. We have an x plus 2 on the top and bottom, an x minus 3 on the top and bottom. And now you're being teased. Boy oh boy, do we want you to cancel out the x's, cancel out the 2's, but you can't. They're simply not like terms, so don't do it. X minus 4 cannot be broken up because that's subtraction. X minus 2 cannot be broken up because it's subtraction. Alright, so while it's tantalizing to do that, they're really kind of dangling that stick out. Don't do it. I think the correct expression is dangling a carrot, not a stick. Who wants to go after a stick? Alright, number 9. We have AB divided by CD. You'll notice that our flip, cancel, multiply has an R in front of it. R stands for reciprocal. You can't actually divide fractions. So instead we're going to multiply by the reciprocal. Whoops, that's not fraction, that's factor. If only I had one of you here to make sure I spell things correctly. C is cancel, and M is multiply. So we're going to actually turn this into a multiplication problem. Okay? I'll be right back with you. Okay, ladies and gentlemen, we are back. So for problem number 9 here, we're going to take the reciprocal of the second fraction. It's always the one at the end. A over B is going to stay by itself. It's not going to change. D over C, I'm going to flip over, take the reciprocal of that second fraction. This becomes a multiplication. So now it's a problem just like the previous page, like problems 1 through 8. I can't cancel anything out of the top and bottom. So I'm just going to multiply A and D together. I'm going to multiply B and C together. You get AD over BC. Reciprocal, factor, cancel, multiply. So every first step in a division problem is actually to rewrite the question. So now this has been rewritten, and we can start to cancel some stuff out. So I'm going to take 3 C's out of the top and bottom. That'll leave 1 C on the bottom. I'm going to take 2 D's out of the top and bottom, which will leave 1 D on top. 16, let's see. Well, 8 goes into 16 two times, and 8 goes into 24 three times. 7 goes into 14 two times, and 7 goes into 21 three times. So what do we have here? 4D on top, 9C on the bottom. A messy little problem. Take the reciprocal of the second fraction. The second fraction. Turn that into a multiplication problem. Then you're going to do your factor, cancel, multiply. All right, number 11. So first step is going to be to rewrite the problem because I have to take the reciprocal of that second fraction. Seem to have changed color here a little bit. Or something's wrong with my light bulb. All right, we have 4 different things to factor. So we have difference of 2 squares, y plus 7, y minus 7. We have, well, this actually doesn't have to be factored, but we should rewrite it. Squaring means multiplying by itself. 2y plus 14 has a GCF of 2. And 3y minus 21 has a GCF of 3. Okay, so, whoops, let's fix that. How many times is 3 going to 21? 7 times. There we go. Great. Let's cancel some things out of the top and bottom. This is the fun part. If you factor and do a nice job with your factoring, you can usually cancel out a lot of stuff. X plus 7 cancels out of the top and bottom. X plus 7 cancels out of the top and bottom. And y minus 7. I don't know why I'm saying x, it's y. Anyways, 2/3 is the final solution. That's the only thing that's left standing at the end of all those cancelings. And that problem is done. 2/3. Alright, for 12. X minus 2 quantity squared. That's x minus 2 times x minus 2. 4x squared minus 16. 2x and 2x, that's the square root of 4x squared. 4 is the square root of 16. We go plus minus here. And if you take a look, I actually made a bit of a mistake. Remember, the first thing you're supposed to look at is a reciprocal. That's not the only problem here, but we'll do that first. So we flip over that second fraction. Now, when we're factoring the 4x squared minus 16, we have to be careful. First thing we'll do is we will rewrite the top. X minus 2 times x minus 2. And here is the issue with 4x minus 16. Let's take a look over on the right. 4x squared minus 16 has a GCF of 4. So if I take it out, I'm left with x squared minus 4. And then I can factor x squared minus 4 as x plus 2 times x minus 2. That's a factoring completely problem. We haven't seen one of those in a while. You take the 4 out, you're left with x squared minus 4, and that's x plus 2. Oh goodness. X minus 2. I'm going to fix that. 3x plus 6 has a GCF of 3, so 3 times x plus 2, and then 21x is going to come along. Alright, I'm going to do some erasing here. I'm going to erase 4x squared minus 16 factored to free up some room. And now we can start the canceling. The fun part, the canceling. I can get an x minus 2 out of the top and bottom. X plus 2 goes out of the top and bottom. 3 goes into 21 7 times. And I think that's it. So I have an x minus 2 on top. 4 times 7 is 28. So 28x on the bottom. Problem is done. Alright. Last but not least, 13. So we have a lot of fractions here, but there's not really a lot to do. First thing I want to do though is over here, I got to rewrite the thing, right? So we have x plus y, x squared plus y squared times x over x minus y, and then remember this fraction has to get flipped and we turn it into multiplication. Now you can rewrite that as x plus y times x plus y anytime you want. You don't have to leave it as x plus y quantity squared. So the only thing that can be factored here is x to the 4th minus y to the 4th. X squared plus y squared, that's the sum of two squares, and that cannot be factored. If you were to graph it, the equation, if I know there's no equal sign, but if you were able to graph it, it wouldn't cross the x-axis. Alright, x to the 4th, y to the 4th. Let's take a look. That's difference of two squares, and if you factor it, you get x squared plus y squared and x squared minus y squared. That can't be factored. X squared plus y squared cannot be factored, but x squared minus y squared can. It's x plus y times x minus y. So you are going to replace x to the fourth minus y to the fourth with x squared plus y squared times x plus y times x minus y. Another factoring completely problem. Let's get the green going here, as this is our last question. So the x squareds plus y's cancel out. I can cancel an x plus y out of the top and bottom, an x minus y out of the top and bottom, and an x plus y out of the top and bottom. Is there anything even left? Almost everything canceled out. The only thing left is an x on top. X is the answer. What you see here before our homework assignment is a summary. To reduce fractions, we're going to factor and cancel. To multiply, we're going to factor, cancel, then multiply. And to divide, we're going to take the reciprocal of the fraction that comes after the division sign, factor, cancel, and multiply. Have a great evening. I look forward to seeing you tomorrow.